Tonight we're doing two mini talks, and our next speaker is Ceal Craig, and she's going to be talking about what? Okay. She'll tell us what she's talking about. You need some setup here. Use the monitor. There it is. Okay.
How are y'all? So my name is Ceal, and Tim's my husband, just in case you didn't know. Many of you know. Or I should say I'm his wife, depending on your point of view. Let me start up again. I'm an engineer, worked in tech, manufacturing, stuff like that, and got involved in robotics because of a student, actually. And I was retired the first time from high tech, and I was teaching for, yes. Yeah, I'm just plugged in. I'm just waiting for it to come up. Thought I would fill. Wait.
Okay. Well, it should be set.
Should be okay. All right. Anyway, I was teaching for Johns Hopkins for 5th and 6th graders, for talented youth kids, and doing science and engineering experiments in the summer as an enhanced camp kind of thing. And one of the young persons in my first class said, "Are you going to do anything on robotics?" Because I had put it together. It was kind of Newtonian physics. We used actually a textbook called Cartoon Guide for Physics. We're great for 5th and 6th graders. And so I called my husband. I'm down in Malibu at Pepperdine and say, "What do you think? What should we do?" So I got this little mouse-following robot that the kids could assemble. And I got 4 for a class of 14, which was a mistake, because they all, of course, wanted to take it home after it got done. So ultimately, then, I built it up over the next years as I taught over the next few years the class every summer. And then I ended up having them take it home. And then a high school called me and said, "Could you coach a team?" And then I got Tim out of retirement and started coaching a team. And hence, I got into robotics, and I'm on the board of directors for WRF. So my first thing I wanted to comment on, though, this is not a WRF presentation. It is totally mine. I'm not representing anybody but myself, so don't think of me as representing the board. Western Region Robotics Forum. We put on a competition for high school students that is a... Pardon me?
You lost the mic.
I lost the mic? Lost? Okay, how's that? Better. Okay, hang on. Doing 2 things at once is a challenge. We put on Cal Games, which is an off-season event, as a so-called off-season for FIRST. FIRST is for Inspiration and Recognition of Science and Technology. It's a international, predominantly North American-based thing. And in fact, the competition's going on right now. Students all over the world are building robots for this new competition. And then we put on an off-season event in the fall. And we do workshops and stuff like that. So when I retired the second time, what I wanted to do was find out why there were fewer engineers than there were in the 80s and before, and why there were still not that many women. So that's my research focus and my doctorate that I'm working on. So what I'm sharing with you here is some of the things that I thought would have some links to HomeBrew, and watching the sharing this evening really brought home, I think, some of the things I'm going to talk about how much HomeBrew can do in terms of reaching out to young people. Okay? So can you see it? Yeah. Looks like we're good. All right. Oh, we got to turn it on. There we go. All right. So, it's going to keep sliding off. All right. Let's start over here. Try that. So I'm going to talk about 3 things. No, it's not good. I'm going to talk about 3 things. Metrics. I'm going to show you some metrics from STEM, science, technology, engineering, mathematics, engineering, computer science. I will consistently show women as part of it, because that's certainly my research focus, and I'd like to get more women in HomeBrew. And I'm going to tell you about how heroes and experiences, both of the things that HomeBrew can offer, really do influence people's career decisions. So you can have a big impact on a young person's life. I'll mention some stuff the National Academy of Engineering is doing called Change the Conversation. I'll bring that in and talk about robotics programs and wrap it up. Okay? So just a couple of charts first. Okay. As you can see here, this is the black line is all STEM, all science, technology, engineering, mathematics. The red line is men, and the dotted purple line, probably can't see it's purple, is women. So there was a steady rise after 1968, 66, until the early 80s. Then it was a big dip. 99, there is no data ever. And then by 2008, which is the last data, it had started to rise again, and in particular men had finally were coming back to their 80s boom. And women, as we'll see in a chart to follow, not quite the same. Now, this one is just engineering computer science. So that prior picture sort of says, gee, things are improving again. Well, if you dig into what I would posit are the fields that feed robotics, like hardware engineering, computer science, and physics, then we're not seeing such a rosy picture. So engineering is the green line here, and we're actually coming back up. But look at computer science, that's the blue line. That's the number of bachelor's degrees we're graduating in the United States. So in the last 10 years, we've had a huge dip in the amount of people graduating in computer science, which is a problem, and will continue to be a problem unless we can change it. Percentage of women in STEM fields is the top black line is biological sciences. Biological sciences, women passed men in over 50%. It's almost 2/3 of the biological science degrees are now earned by women. Chemistry is about 50-50. Math is about 50-50. However, physics, computer science, and all of engineering is not. So that yellow line kind of shows the 50-50, and it shows that in the physical sciences overall, which includes chemistry, we're doing better, but engineering kind of flattened out. It's that dotted purple line at the bottom, the smallest line, and the other dotted line is computer science. Now, if we look at just those three, engineering, computer science, and physics, the percentage of women in those is declining or stagnant. Look at that computer science one in the 80s. A third of the graduates of computer science were women. That has changed, and it's been going down to like 12% last year. So, now that's data, it's a bunch of graphs. What I'm trying to get across is the three fields that I would suggest are probably good feeders for robotics. We're declining with the number of graduates in the United States, and in particular in women. If you look at, I've also got a bunch of graphs I didn't show in terms of different underrepresented groups and all that kind of stuff, but if you want those, I can send those later. So my dissertation is all from a career theory concept. What are the things that influence young people's career decisions? And this circle you have up here says there's a lot of things. Think back to when you made a career decision. Was it a person? Was it an experience? Was it your parents who said you will do this? Did you want to do it? Were you here when you were a young man or woman, young girl or boy, experimenting with robotics, trying to figure out what I'm going to do with my life? What are those things? Well, experiences and role models are two particular influences that really come home for STEM, or any kind of science, technology, engineering, mathematics. The other thing, the common one you might think of, personality characteristics. Yes, average to high IQ. Doesn't take a high IQ, doesn't take A's in math and science. Might to get to certain schools, top notch, but if you want to be an engineer or scientist and you get B's, you can still be one. If you've got D's in all those classes, more challenging. But if you can understand complex relationships, if you're independent, a problem solver, you like solving problems. That's what engineering is all about. And so that's what the theories tell us. Now on the right-hand side, the other thing the theory tells us is that heroes, role models, teachers, parents, those are all heroes. They influence, and they can influence a person in an hour's time, in 10 minutes time. They present a project, you listen to them, you treat them as a peer when you're discussing something, has a huge impact. Science projects, science kits, judging at a science fair. I judge at the International Science Fair as often as I can afford to go and do it. But that influence you have with those young people and what they go on to do. That's why I'm involved in robotics. But heroes influence choices. And heroes are not just that teacher, that mentor, it's the parents. So if you're a parent, you have a huge influence, more than maybe even you realize. So robotics programs do provide those kind of experiential opportunities, because that's the other piece that career theory says that I'm not sure I emphasize. Because if you can touch it, put your hands on it, experience with a couple different senses, you remember it. There's lots of research, and that's what I usually show to a research community, that shows that there have been studies that eminent scientists, eminent engineers, young people, whatever, they often will come back to say it was a particular book, it was a particular, like Camp had said, there was a particular person I heard, or I talked, or I was involved in this thing, I went to this camp, I did this. That's what got me interested in going into science or engineering. It shows the relevance of math and science. That is somewhat important. And some examples for that to give you a range, besides the typical thing you hear from CalGames, WRF, is middle school 4-H project. They use Legos to teach STEM concepts. In particular, in that one, they also did another one, was teaching evolution concepts. What they found was, this was a study in Texas, as I remember, New Mexico, but it was for non-English native speakers. And so having a hands-on Lego experience to teach evolution, they were able to get across the fact that they didn't completely understand the English. So that's another benefit. And then first, one of the things that I'm active in some way and trying to study has that as well. So these are some examples. This is a number of things from the Girl Scouts team and some things from Maker Faire, actually. That top one picture says WRF. The thing I was trying to get across with these pictures is there's excitement in this. You go to a competition, and for those of the homebrew guys who have judged, you get a feel for that. It's those who attended. I mean, it's noisy. I often will have my little ear things in, and people are cheering, there's mascots. It's just a lot of fun, and it is a competition. So, but you get to design it, you get to build it, and get to run it. But you need engineers, technicians, parents, scientists, people to be working with those teams. That's what we need more of. So mentors like yourselves, if you were working with a team or with a young person on a project of some type, you are an influence. You become a hero to that person, can be. You can also be a negative hero if the student doesn't really like the way you treat him or her, but it does have that. Now, studies say mentors in particular have an impact on girls. Girls really respond to that. Boys are somewhat socialized to go into this kind of field. Girls are not. So a mentor, male or female, black or white, Asian, non, whatever, a mentor takes a sincere interest in that person, that young person, can have a big impact. That's what the studies will tell you, or are telling us. Parents make a big difference for girls also. Setting expectations. If you say, gee, I think you can do that. I mean, when I just came back from a National Science Foundation program, when I was a junior in high school, my parents were very receptive when I came back and said I want to be an engineer. That was 1969. You know, I was one of 66 mechanicals when I graduated in the United States. So there weren't a lot of women out there in engineering. I wasn't getting a lot of encouragement from other places. But I got it from my parents, I got it from my teachers. And that's consistent today. Still the same kind of thing. Also, teachers influence girls a lot. Now, the next piece I want to mention is that the National Academy of Engineering has recognized this. If you go back and look at the way we as engineers or scientists have talked about our profession when we talk about it to young people or even to the public, we're often telling stories. I know my husband's told one story. Oh, you know, when I was a freshman, they told me the person on either side of me would be gone by the time I graduated, you know, and so on. And there's all those stories about how hard it was. That's what a lot of people hear. What the National Academy has found out is that we have to change the conversation. We have to talk about why engineering is fun. Engineering is all about creative problem solving. Show, don't tell. Engineers make a world of difference. A lot of young women, as well as young men, want to make a difference. They want to go into a field that really makes a difference out there, solves a world problem, solves energy, whatever. And they help shape the future. So how we talk about engineering, how we talk about robotics, how we talk about what we learn, why we like it, makes all the difference in the world. So check out the website, engineeringmessages.org, if you're looking for some stuff on that. So summarizing. STEM has been getting bigger, but even though men are earning more engineering, computer science, and physics degrees than women, we're still not getting quite enough of them that we need. Men and women share a lot of other fields, but I like to see personally more of them in engineering and computer science and physics. Teen career decisions are influenced by two things that you guys do. Experiences that you provide them with the kind of thing you're doing here, and the kind of heroes you can be in the way you treat them and talk to young people, and how you demonstrate it. And we need to change the conversation about engineering. It really is about encouraging young people. So, mentors can inspire and challenge young people, and I just wanted to leave you with a question, what can HomeBrew do? And this was a new quote I found from Grace Marie Hopper. I imagine some of you may know who she is. I met her when I was in college, and she's a very inspiring woman. It's where the word bug comes from. I'm sure you've heard that, right? You know where the software bug, I see some people that don't seem to know that.
Not the story I heard.
Pardon me?
Bugs came out of the very early computers.
Well, there's actually...
calculating computers and actually found big bugs.
Well, actually, she did. If you look at her, there's some stuff, I want to say it's actually at the Smithsonian where I saw it. There's actually her journal. And she put in there, she taped in there this moth that caused the ENIAC to come down for the day. And so she called it, I think this was a bug that brought the computer down. And so she has attributed to it, that's where the word came from. I think it was 1952 or something, 53. But yeah, thought that was pretty cool. Okay, so that's it. All I got. Any questions?
I have a question.
Yes.
So did you say you had some experience working with grade school students with science and technology? What do you see as the best way to motivate grade school, like in the 3rd to 6th grade range, when they can start to understand math and science? What's the best way to motivate them?
Well, a caveat, I have been focusing most of my research that I've been looking at on adolescent. Okay, but one of the studies I'm looking at right now is in elementary. It's when they're first starting to form cognition and pathways, and I'm not sure I have the right psychological words, but it's when they're first starting to form a concept of themselves and what they think they're good at. And so the more you can actively get them engaged with fingertips, that's what I've seen. Now, when I was doing the program in the summers, it was predominantly all about experiments. I would do, at most, maybe 10 minutes, 5-10 minutes from the cartoon guide for physics. We'd go over Newton's first law or something. But then it was build a bridge, do a roller coaster for the day, experiment, play, here's the math involved, if there is any, just some light stuff. So it's these little interspersing kind of things. Do you have something you want to add?
No, I have another question.
Oh, okay. So let me make sure I finished it. And I could give you some more data on that if you want. I've got some curriculum I could share with you. I was going to point you to Design Squad Nation. If you haven't heard of it, PBS Boston has this thing called Design Squad Nation. It's like a reality show where they have engineering colleges competing against each other. And in their site, designsquadnation.org, there are all these videos, materials. I've used a couple of them with high school and adults just to get them engaged, and they're incredible, the response. So, yeah, go ahead.
So did you try using prizes to motivate students?
Well, prizes seem to, from my memory of the research, seem to motivate boys more than girls. Not completely. I mean, the girls are competitive at some level too, but they motivate differently. And not all boys react the same way, and not all girls react the same way. But certainly prizes like first, there's, you know, who wins makes a big difference. But I don't know, it's interesting. Interesting question. Thank you. Yeah.
When I was a kid, everybody was nuts about the space program and stuff like that, and I don't think they have anything like that right now. And I was wondering if there's anything that we could do for an inspiration for school, because it seems like our culture. I mean, I don't want to name names, but like about 30 years ago, the culture just sort of lost its idealism, or for as far as science was concerned, anyway. And I don't know if you see any of that, or.
Well, yeah, you're right. I mean, you can see that 30, 40 years ago, 25, 30 years ago, we had a lot of changes. But what motivated someone back then might not be the same thing that motivates people today. That's one message, I would think. The second point is, I'm not sure there's one singular event, and I don't disagree. 69, when I was the NSF program, I was in that dorm in the summer, away from home, doing all this great stuff. And we watched Armstrong walk on the moon.
Yeah.
So I remember that summer
I do
incredibly.
too.
Okay.
Yeah.
But today, we may not have one singular event. We have lots of events. We have things like Google, this huge growth, and what's happening there. We have biomedical exploration. The energy thing. You know, I think the energy issues that have come up, Friedman's Hot, Flat, and Crowded certainly talks to that. That there are some big world problems that could be that same kind of inspiration. But it would be interesting. Take this one back there and then there and then there. Yes.
It looked like in one of the older graphs there was actually more female computer science students
Yep.
than male.
That's right.
And what do you think did that? Like the punch operating and being able
No,
to
no, no.
type, or
No, not from what I've seen. I mean, when I was, a couple of things. Computer science began to get in the 80s, if you think back to 80s, early 80s, okay? Early 80s was, I'm trying to think, timeshare was late 70s.
Workstations are early.
Workstations just starting.
First PCs.
Right, first
PCs
PCs.
and
Okay.
workstations, yeah.
Something happened there where women stopped seeing it as an interesting career. One of the things that I think rose, there's another graph I have from another presentation where I said, well, is there just a finite pool of people? And if they don't go into engineering and physics, do they go into biological? You know, okay, up and down. Well, that's somewhat true at that time. A lot of people went into the biological sciences because I think that's where the big growth with the gene
But how did it
various
get
stuff.
to be the dominant, I mean, computer science, you know, that was again, more women than men.
Well, no, the women never were dominating computer science. They were up to about a third. They're at about 33%, 35%. That was their peak in the early 80s.
Yeah, I mean, no, that one graph though, it actually looked like they were in charge.
No, I think that was something else that I didn't show the scale properly.
Okay.
Sorry. Okay. You had a question over here?
Well, someone over there first.
Okay. Whoever, I lost track.
For your recent drop-off, did you look at the spread, again, the hypothesis you made earlier about the finite pool, did you look across the spread of choices that girls had, and was there some other more popular choices?
I see what you're saying. I think what you're asking is, at that time, were there less choices and there are more choices now that might be sapping it? Is that what I'm hearing?
If you look at the distribution of where a pool of girls would go across the professions,
Yeah. Well, I can
did
tell you
these
where.
shift, and
yeah.
how did they shift?
Well, I can tell you where some of them went, right, from the data, is all bachelor's degrees in 1981, which is right about that peak. Women earned 50% of all bachelor's degrees, not STEM, all bachelor's degrees. And it's been rising ever since. There are more women that earn a bachelor's degree in college than men today. Now, one of the things that happened, two things that started to rise in that, you'll see some rises in numbers, is finance. That's one big one.
Yeah.
And then also a lot of women started going into medicine and law, the other professions that are a little softer at some level. And men as well, because you know that's where the men's numbers dipped as well. And I know a couple of guys that I worked with, our CFO was our judge, you know, for the entrepreneurship award. To me, whenever I talk to him, I think of him as in many ways, why didn't he go into engineering instead of finance? Well, he was really good at math, but he's just that much younger than I am, right about that time that finance was the up and coming thing, and it was a little bit easier.
There was another phenomenon about finance that happened in the I think it was around the late 70s, early 80s. The physics community, the high energy physics community shut down all the small machines in favor of the Fermilab and the big accelerators. And a lot of physicists, in fact, a good friend of mine, very well qualified physicists, had no place to go. And what happened is the new physicists that were coming out were, in fact, lured into the finance physics. That's where all the so-called quants came from on Wall Street.
Well, the one thing I do remember about the physics degree is usually the one I use when I'm doing a different slant to this, is the sheer number of physics bachelors has not changed in 40 years.
Yeah, except the outlet.
The sheer number, 10,000 roughly a year, is all we graduate in physics. Hasn't changed.
The output for employment decreased.
But yet it stayed the same. It's just sort of stable. It hasn't grown either like the others. Yeah, there's been a lot of other changes that occurred. We had a slight recession at that time. You know, a lot of different stuff. Any other questions?
Yeah, I sort of had a flurry of comments I wanted to make, but I'll try to reduce it down. I was in Target the other night. The gentleman was talking to his daughter and saying that you can do anything. When someone tells you you can't do something, that's not right. You can do it.
Right.
So I said, hey, Dad, what about when the teacher said that? He says, that's who told my daughter that. I said, what?
Yep.
Yeah.
Yep.
So still 2012, being told you can't do, this is a boys thing, this is a girls thing.
Yep.
So
I still hear it.
1.4 budget, $1 billion budget, getting ready to hit shortfall, getting ready to get hit in 12. It's only going to get worse. So what could HomeBrew do? I'm not a member of HomeBrew, but I think figuring out what the local schools are doing, really, and trying to create opportunities outside of school, learning opportunities outside of school, like the Google fellow who just left Stanford, who's now who's got addicted to having an AI class being offered to 10,000 students worldwide.
Yeah.
It's going to change everything.
Well, I think, picking on what you said and linking it back, what we thought of if we grew up in engineering, I did with a Sligo through college, we can't use that paradigm today. You really have to kind of turn it around and say, what will appeal to young people today? Okay, so that's why I'm going, since I've done this research over the last 3 or 4 years, my mind on some of this has changed. And the National Academy piece, where they've studied that to try to see what appeals to the digital generation, young person, and so on. So we do have to, it's not completely changed, but there is this nuance to it.
If I could quickly follow up, the schools are currently fighting it tooth and nail. They're fighting it. They see what's coming, they see what's happening, and they're fighting it. They don't want to let go. Okay? The cost is still going up. Everyone's, pretending it's not happening. Who can afford it? Now you have to go into debt to be able to pay for it. Santa Clara's almost 250,000. Okay? UC's going up, CSU's going up.
We missed this slide.
Just go from your excellent talk. Thinking about the first part of engineer is engine, so hands-on is good. And I would think that the first program would be a strong impetus, because that's where you go out and you bend it to fit and paint it to match until it works. There's some interesting possibilities going forward, it seems to me, in robotics, because it's not really obvious, but we've just about now really turned a corner in robotics for the outdoors, if you will. And I'm not talking radio control, because
No, DARPA, for example.
Yeah, the DARPA challenge, okay, so there you've got robots running across the desert, so to speak. And that gets more interesting because eventually I think a lot of robotics is going to be semi-automated, as in for menial tasks you could turn it loose, you know, if it's just going to do one simple thing. But it's more interesting to direct it, and if it goes more outdoors and you're making these specialized machines to go outdoors, that looks to me like a challenge.
Right, 2 points. One is, and I wish I had the exact quote, but just reading it, what you might assume works for men and boys does not necessarily work for women and girls.
Hmm.
Now, I'm not speaking against FIRST or for FIRST. My only experience from what I've seen is FRC teams, FIRST robotics competition teams, who have only one girl on a team. That's a really hard road to hoe.
Yeah.
Okay. If it's an all-girls team, that comes up with a whole different dynamic.
Mm-hmm.
So my study proposal is to do a qualitative study on how it affects young women's career decisions in after they're now in college,
yeah.
so years later. I don't know what the answer is. I'm curious. I've dedicated 10 years to this, and I want to know if it really works.
Yeah.
Whereas the second thing, yeah, I think robotics, that's why I do think robotics is a big key part of how this could turn around. You were asking what could be a big major event. Well, it could be what that is. And if you look at the Gardner Group report that talked about the future of robotics recently, they certainly seem to be predicting some change. Now, for Gardner Group to finally start to say that, from my experience, says that something might be happening.
Yeah. Besides being a FIRST mentor, I was also a Bachball mentor. And Dave Miller, who was the founder of Bachball, would always give this speech. He says, when people talk about STEM education in elementary schools, you always come back to 4 things: dinosaurs, astronomy, biology, robotics. Astronomy you have to do at night. Dinosaurs are all dead. Dissecting frogs stink. Robotics is the way to go.
I'm sure if there are many more questions here, we could go on all night. So why don't we just come on up here and I'll give you one more question, okay?
Okay, so just because we're talking about like getting kids involved in stuff like this, I'm going to put in the shameless plug for Hack the Future. Is on Saturday at the San Jose Tech Museum, and that's where a bunch of mentor-y people, I guess like you guys, shows up, and kids show up, and the PRC is going to be there, and we have a bunch of stations, and it's pretty free form, and yeah, we've had it twice before, and it's been pretty good. Everyone went home happy. So if you know any kids who want to go or something, or you want to like or if you want to get involved in that for like later events, look up Hack the Future.
If I could close on building on that, the one thing I would say that a HomeBrew could do, if they wanted to actually take this as a project to do something, would be to, I went to a Society of Engineers conference in October, and you know, typical professional engineering conference. Saturday, the last day, I had an option to commit myself all day to work with, I think it turned out to be 400 girls between 4th and 7th grade. And Design Squad Nation, I want to say ExxonMobil, but one of the large companies helped fund it and so on, and a number of sweet people who were there for the conference, as well as Design Squad. We all never had met. A couple of folks that organized the whole thing, and we spent all day doing 3 experiments with I had a table of 6 girls I'd never met. Spent that day doing these experiments, trying to help them build a can holder, trying to think what else. I've got pictures of them. But that was phenomenal. So for Robot Week, Robotics Week, or something like that, if HomeBrew did a one-day, try to get kids to come, mentors there, have some set experiments on robotics that young people could do, it'd be pretty interesting.
Comment that we've always known that Wednesdays nights are not a good night We don't have nearly as many families who can show up because kids have to go back to school in the morning. So, but we've talked about moving the meeting to another day, and we always come with the conclusion that we just don't want to go there. So, but you know, it would help if we had a different meeting time. Okay. Thank you very much to both of our speakers. Okay. We'll be meeting basically next month, probably in a different location. I don't recall what we got for the location. Patrick will be giving a speech on basically machine learning, right?
We'll say computer vision.
Computer vision, sorry, I got it wrong. I got it confused with camps. So please come to our next meeting, and with that, have a good rest of the evening, and have happy robotics.
Who wants to take the turtle bot home?